So commonly we use different type of units, and so it's important to be able to convert one unit to another using those conversion factors given in the reference table. So, and this process using units as a guide to solving problem is what we call dimensional analysis. So for most conversion problems, we're usually given a quantity in some units and asked to convert the quantity to another unit. So we can simply find the conversion factor between the two units and use the given unit and use the conversion factor. We can calculate the desired unit that we're looking for. So for example, convert 32 nanometer to meter. All right, so first, n is a prefix of 10 to the negative 9th. So 1 nanometer is equal to 10 to the negative 9th meter. Now, to solve the problem, we start with the information that's given to us, which is the 32 nanometer. Now, based on the conversion factor, we can also write two fraction conversion factor, which is 1 nanometer per 10 to the negative 9th meter, or 10 to the negative 9th meter per 1 nanometer. They mean exactly the same thing. It's just two different ways to show the conversion factor between nanometer and meter. Now, since we're starting with nanometer, we're looking for meter. So the principle is that the unit you're looking for is always on the top. Okay, so now we want meters on the top. That's why we're going to use this fraction where meters is on the top, nanometer is at the bottom. Now the nanometer can cancel out. You can calculate meter using your calculator. 32 times 1 times 10 to the negative 9th. We can calculate the meter is 3.2 times 10 to the negative 9th. So when you're solving problem, always make sure the units are correct and consider if the magnitude of the answer makes sense. So it is helpful to write a conceptual plan, basically where you can identify the starting point, that is a given information, and identify the end point. It's what you must find. And then we derive a way to get from the starting point to the ending point by looking up the conversion factors or whatever relationship you should know or you can look up. So for example, convert 1.76 yards to 2 centimeters. So based on the, so first thought, we have to make the connection going from yards to centimeters, right? Then you can look up the reference sheet in the back of the textbook. There's a conversion factor table. There's no direct conversion going from yard to centimeters. So we have to find a middleman, right? So we can find the conversion factor between yard to meters, and then we know we can convert meter to centimeter. So now instead of doing one step, we're required to do two steps. And keeping in mind, there's more than one way to get from starting point to the end point. Okay, so now start with, so 1.76 yards. That's what we are given, the starting point, right? And now the first step, we're going to convert a yard to meter. So from yard to meter, we want to use the fraction conversion factor where the meter is on the top as a numerator. And then the yard should be at the bottom as the denominator. Okay, so now which is 1.76 yard times 1 meter per 1.094 yard. And yard can cancel out. Now we have the meter we need. So we can convert meter to centimeter using the conversion factor between meter to centimeter. Okay, so 1 centimeter is equal to 10 to the power of negative 2 meters. Now we want centimeter, right? So the centimeter should be on the top. So 1 centimeter per 10 to the negative 2 meters. And meters cancel out. So now the only unit we have left is centimeter. All right. So now you just need to use your calculator to do the calculation using 1.76 times 1 over 1.094 times 1 over 10 to the negative 2. And then finally, let's check the significant figures of the number. All right. So 1.76 has 3 significant figures. So since in the conversion factors, all the numbers are considered exact, so we don't consider their significant figures. Your final answer should have the least amount of significant figures, which is 3. And we round it up, so it's 161 centimeters.